The muscle body is encased in which of the following? A. The paramesum. B. The epimesum. C. The endomesum. D. None of these. The answer is B. The epimesum. The muscle body is encased in a fibrous elastic sheath called the epimesum, epi meaning on or above and mes meaning muscle. It is composed of dense irregular connective tissue and is continuous with tendon fibers. The paramesum surrounds muscle fascicles, while the endomesum surrounds muscle fibers. Which of the following correctly describes an isometric muscle contraction? A. The amount of muscle tension increases without any change in the length of the muscle or the angle of the joint. B. This form of contraction can either be eccentric or concentric. C. There is a rapid burst of mechanical energy for a short powerful movement. D. The length of the muscle shortens and the angle of the joint changes during the contraction. The answer is A. The amount of muscle tension increases without any change in the length of the muscle or the angle of the joint. Isometric muscle contraction are those in which the tension in the muscle increases, but the muscle does not change length, nor does the angle of the joint change. An example would be attempting to push or lift an object that is too heavy to move. This is in contrast to isotonic contraction, in which muscle tension remains constant, but the muscle length and joint angle both change. During contraction, the A band of the sarcomere does which of the following? A. It lengthens. B. It thickens. C. It does not change. D. It shortens. The answer is C. It does not change. The A band in the sarcomere is created by the bipolar myosin filaments, joined at the M band. During contraction, the heads of the myosin filaments bind with the actin filament and pull it toward the M band at the center of the sarcomere. The myosin filaments do not themselves change length, and because of that the width of the A band does not change during contraction. In the sliding filament theory of muscle contraction, all but which of the following are functions of ATP? A. ATP does all of these things during muscle contraction. B. It moves the myosin head into a high-energy cocked position. C. It allows the myosin head to detach from the actin filament. D. It moves tropomyosin off of actin binding sites. The answer is D. It moves tropomyosin off of actin binding sites. According to the sliding filament theory of muscle contraction, ATP binds to the myosin head and is hydrolyzed to ADP and inorganic phosphate. The energy released during this change draws the myosin head back into a high-energy state, from which it is able to bind with actin and execute its power stroke, leading to muscle contraction. ADP and inorganic phosphate then are released from the myosin head and replaced by a new molecule of ATP, which allows the myosin head to detach from the actin binding site. All of the following features are unique to cardiac muscle cells except A. They form branching chains. B. They are linked together via intercalated discs. C. They are non-striated. D. There are gap junctions between cells. The answer is C. They are non-striated. Cardiac muscle cells are striated, branching cells that are linked by structures called intercalated discs. These discs are composed of gap junctions, which allow the free passage of electrical signaling between heart cells, and very strong attachment points called desmosomes. A nurse is examining a patient who has muscle pain and fatigue after working out. He determines that the patient has muscle strain. This is generally caused by which of the following? A. There is damage to ligamentous attachments. B. Excessive contraction causes tetany in the muscle body. C. Hypertrophy is causing swelling of the muscle fiber. D. The actin and myosin filaments have been pulled past their ability to overlap. The answer is D. The actin and myosin filaments have been pulled past their ability to overlap. Muscle strain is often caused by overstretching, during which actin and myosin heads are pulled to the extent that they are no longer overlapping, possibly to the point of causing tears in muscle tissue. Tears in ligaments are sprains, rather than strains. Which is the only muscle type that is non-striated? A. Skeletal muscle. B. Cardiac muscle. C. Smooth muscle. D. Voluntary. The answer is C. Smooth muscle. The only type of muscle that is not striated is smooth muscle. Smooth muscle does not use sarcomeres for contraction, rather, each muscle cell is a spindle that is covered in a mesh of contractile fibrils. These fibrils contract in unison when calcium enters the cell. Which of the following is the smallest unit of contractile tissue in cardiac and skeletal muscle cells? A. The sarcomere. B. Actin filaments. C. The myofibril. D. Myosin filament. The answer is A. The sarcomere. The smallest contractile unit in muscle tissue is the sarcomere. Myofibrils are made up of many sarcomeres attached end-to-end at a series of dark lines, hence the term striated, called Z-lines. Each sarcomere contains actin and myosin filaments, which pull together during contraction to shorten the sarcomere. The sliding filament theory of muscle contraction involves the dash attaching to dash and then pulling during the power stroke. A. Myosin. Tropomyosin. B. Myosin head. Actin. C. Actin head. Myosin. D. Troponin. Actin. The answer is B. Myosin head. Actin. The sliding filament theory of muscle contraction involves the myosin head attaching to actin and then pulling during the power stroke. Troponin is a protein attached to tropomyosin, a thin strand wrapping around the actin filament. When calcium enters the cell, troponin moves toward it, pulling the tropomyosin strand away from actin binding sites and allowing the myosin head to bind. Which of the following molecules binds to troponin during muscle contraction? triggering tropomyosin to move away from the actin binding sites and allowing the myosin head to form a cross bridge. A. ADP. B. ATP. C. Sodium. D. Calcium. The answer is D. Calcium. During a muscle cell action potential, calcium enters the cell via T-tubules, which are specialized invaginations of the sarcoplasmic reticulum. Calcium binds with troponin, which pulls the tropomyosin strand away from actin binding sites and allows myosin heads to bind. Neither sodium nor potassium bind to troponin, and ATP and ADP both bind to myosin, rather than troponin.